Now, next part is the programming part. So it was for developers. So we'll dive into the programming part. Well, okay, so we'll start with the coding part. So I will start with the Python programming, and Dr. Balaji will take over for the Java part. Now in Python, what my focus is on means usually when I take classes, I start from writing the code line by line, but we have a time constraint. So I will explain line by line rather than writing. Now when you start using Python, there are several libraries. You search like RSA encryption Python, you will get so many libraries. And there are some very easy to use library, but they are not secure. So if you check their documentation, they will clearly say that we have this shortcoming. So if you are using for production, don't use me. So always be aware of what packages you are picking and from where you are picking. Now, so I will, for my demonstration, we use cryptography package. So cryptography package, if you want to install, so for Python, you may be knowing you just have to do pip3 install and the package name, for example, cryptography. Now currently I am not connected. I will have to connect to internet. But if you use that, cryptography package will be installed. Now in cryptography package itself, all the required tools, for example, you require for hashing, you require for X.509 certificate creation, name object identifier, everything you will get in this itself. For signing, for padding, so everything you will get in here. So the first part of this program is to basically hash. So if you want to hash a message, there is one library, hashlib. So you just have to import hashlib in the first line, and then in the you can define a function for hashing a message and pass the message as the parameter. And in the hashlib library, you can define which hash you want. For example, here I have taken hash 256. I have passed the message by encoding it in UTF-8, and then finally, so that the final hash looks good, I am using hex digest, which will basically convert it to hexadecimal representation. And after that, I am simply printing whatever hashed message is there. So hashing is too easy. Just import hashlib, then hashlib.sh256, pass it the message in the encoding UTF-8, and hex digest, which will simply convert it to a hexadecimal object. So we'll see this. I will just uncomment the last line, hash digest hash message, and we'll see if it is working fine. So I'll go to the command line and Python 3 and RSA sort.py. So you can see that it has generated the message hash. Now next. So next part is we have to do encryption decryption, but for that first we need to generate the key pair. So for key pair generation, so I have defined this function generate RSA key pair, in which I will pass the key length and private key password. So basically, since it's a soft key, so private key, either you can encrypt it using a passkey, or you can put it without encryption also. It's a soft key anyway. Now to generate this, the RSA, there is a RSA which I have imported from the cryptographic package. Now most of the time we think that how will I remember this big package name from where to import? But if you are using any IDE, so IDE will help you in importing the right package. Okay, so that helps. You don't need to remember from which package I have to import it. So for generating a key, we have the function in RSA module, which is generate private key. In generate private key, I am passing the key size, which is basically key length. For example, I am using RSA, so 1024 or 2048 bit. Once I have generated the key, I am storing it in this private key variable, and then I have to store it in some file. So for storage, we need to serialize it. For example, you may have seen about PEM format, in which I can store any public key, private keys. So for that, this line is there. So I'm encrypting the private key and serializing it using the PEM format, and the private key format is basically PKCS8. So I'm also defining that what will be the format for the private key. And finally, there are two things. One I have commented so that you know that this happens. One is serialization dot no encryption. So I can, without encryption also I can save it. And second one is where I am encrypting it with the whatever passkey is there. Okay. So both are there. We can try both. So that was the private key serialization. Then from the same private key, it contains basically both the public component and the private component. So I can extract the public component using public underscore key function. Again, same thing, I am encoding it to the PEM format, and the whatever public key information is there, which will be stored in the file. So now my files are here, but I have to write it to the actual storage in the operating system. So for that, I am using two files, private rsa.pem and public rsa.pem. So these two files I'm just opening. So this is the standard syntax in Python for opening a file. So I'm opening a file in writable mode. So it is WB is basically writable binary file. So I'm opening in that, and then finally I am writing using the write function. So whatever PEM serialized private key and public key are there. So in first attempt, I am writing the private key, and in the second line, I am basically saving the public key. So I generated, converted to PEM, and then finally I am saving it in the OS using the write command. And finally I'm printing. So let me try with, I can try with suppose 2048 bit, and with passphrase I will save it. So currently if you see, I have only two files, ec_sort.py and rss_sort.py, and now I will generate it. So let me run this again. So you can see RSA key pair generation is successful, and if we come here, you can see here there is one private RSA which says begin encrypted private key, and second one is the public RSA which is simply begin public key. So two keys has been generated. Now next part is the encryption part. Now for encryption, the general convention is that we can use the public key of the receiver to encrypt anything. So here we will do the same thing. So we'll open the public key. So for opening the public key, you can see RB is the mode, read binary file. So I am reading it, and using serialization, I am loading the key. From the file, I am loading it into this variable public key. After that, there is a encrypt function, inbuilt encrypt function. What does it take as the parameter? So one is the message. So I will take the message, encode it in UTF-8, and then I have to define the padding. So you may be aware about padding, that if the there are block ciphers, so if the message is not sufficiently large, or maybe it is over large, so in that case we can have paddings so that it becomes a full block. So in this case, we for RSA encryption, the latest secure is OAEP, which is basically optimal asymmetric encryption padding. So that I am using. In that also, I am using a mask generation function. Mask generation is basically kind of hash which generates a variable output. So we know that hash functions always produce fixed, but using mask generation, I can produce different block sizes. And for that, I am using SHA 256, and done. So that's all it takes. So already I am considering the public key to encrypt, and I am passing the message, and I am defining that what padding schemes it should use. And finally, I will print the cipher text in hexadecimal. So that's why .hex, so that it looks better. So let me run this. Now this passphrase I have already made as a variable earlier. If you see here, passphrase dev training, so which will encrypt the private key. Okay, so we'll run again. Let me comment out the key generation part, because we already have generated and saved the key. So it is giving me the encrypted message in the hexadecimal format. Now, just opposite of the encryption part is the decryption part. Difference is that encryption was done using public, so the decryption will be done using the private key. So I am reading the private key, loading into the private underscore key variable, and finally I am calling the decrypt function, which will again take two parameters, the padding and what do you want to decrypt. So this time my decryption is on the ciphertext. Earlier it was on the message or the plain text. Same thing, everything I am using the same mask generation function, and the padding scheme is also again OAEP, and this way the message will be decrypted. So basically whatever I encrypted, for example, hi, I am Anoop Pandey, so I should get it back the same thing. So I will just uncomment the decrypt message and run it. So you can see that I'm getting the same decrypted message. So anyway, it was obvious. Okay, so now we'll focus on the signing part. Now signing part, this time it is opposite. So I have to take a private key for the signing, and for the verification part I will use a public key. So that's why for the signing part I'm opening the RSA file, private rsa.pem, in the read binary mode, and loading it in the variable private key using the serialization package. And of course I'm passing the passphrase because the file is encrypted. So I need to pass the passphrase so that it will decrypt and load. After that, I'm calling the sign function, private key.sign, in which I'm passing the message that needs to be signed and the padding scheme. Now in encryption we use OAEP, but for signing we use PSS, which is basically probabilistic signature scheme. So it's a different, so for signing we use PSS. Earlier it was PKCS 1.5 version 1, but the latest one, which is 2.1, is PSS. So we should use PSS only. And finally, in the signing part, we also have to define what hashing algorithm should I use. Because as Dr. Misbah was saying, that first the message has to be converted to a digest using some hashing algorithm, and then that should be encrypted with the private key. So I'm telling that we should use SHA 256. So in that way the digital signature will be generated. So let me uncomment this function call. Okay, so I did not comment the encrypted part. I will comment it. So this is my digital signature in the hexadecimal format. Now the verification part will be simply opposite of whatever we did. So I have a signature. Earlier I had a message, now I have a signature. I have a message, and then I need public key for verification. So I am importing the public key, loading the public key basically, and then I'm calling the verify function. So already inbuilt function is there. I'm passing the signature, I'm passing the message and the padding scheme along with the hashing, which hashing was used. So if it is successful, the digital signature is valid. Otherwise it will tell that the verification failed. So for example, let me run it. So so currently the digital signature is valid. So as you had seen that we can try to modify the message on learn.pkindia.in, and if so verification should fail in that case because the decrypted hash and the hash that we generate both will not match because the message will be changed. So let me try here itself. So like here, hi, I am Anoop. Earlier I had signed hi, I am Anoop. Now this is the message. I'll just add one space. That's all. And try. So it will say that it's an invalid signature. So that's the signature verification and the signing part. And last is basically how can I generate the certificate. So we have to create a digital signature certificate. Now earlier also it was told that if you want to generate a certificate, then you have to provide some information, country, state, locality, Then, so I'm just taking input one by one: country, state, locality, organization name, and the common name. So common name is basically for whom the certificate is being issued. Either it's a person or some FQDN if it is a server or a machine. So once I have taken this as an input, then I'm passing it to this X509 module. So it will convert it to the object identifier and save it into the subject. So basically all these information belong to a subject to which the certificate is being issued. Now this certificate, currently I don't have a CA. So I will use the self-signed certificate. So for self-signed certificate, the same subject is the signer also. So for the same subject, I am also opening the private key because he has to sign using that private key. So I'm opening the private key and loading it into this variable. Now another thing is the certificate builder, which will basically build the certificate. Now what does it require? So first thing it requires is the subject. So subject, just now we created this subject X.509 subject. Second thing is issuer. Now it's a self-signed certificate. So again, subject, it's the same subject. Public key, because it has to have a public key in the certificate. So from private key, I am deriving the public key. Serial number, I am randomly generating. So random serial number, it's already a function inside X509 module. Validity. So, so not valid from and not valid after. So a starting validation, validity period is starting and the ending date. And finally, sign using the private key. And for that signature, the SHA 256 will be used. So I will repeat. So I have a subject, then I have the issuer. So it's the self-signed, so same subject. Then I will have to store the public key, serial number, randomly generated, validity from, validity to, and finally sign using private key, and the hash function is SHA 256. Then I simply have to open one file in the write mode, give it some name like common name certificate.pem, and after serializing it into PEM format, I am writing this file, certfile.write, encoded in the PEM format. Binary. B is for binary. So in Python we use small this string literals, like F is for formatted string literal, B is for binary. Okay, so now I will uncomment this. And run. So country, so certificate is generated. So I will just see where is the certificate. So I have stored it on desktop, demo, and this is Balaji R certificate.pem. I will open it. It's a PEM file, certificate file. In Mac, it will open with the cloud keychain. So for that, I will pass my biometric. So here I will just search for certificate. So this is the certificate, Balaji certificate. You can see it expires on 26 February 2025. It is too small, but believe me, I am saying it's 26 February. So I can open it and same IN Delhi ISC CDAC Balaji. So this is a self-signed certificate which has been generated just now, 27th Feb at 3:56 using RSA. So that's the RSA encryption. Now, second part, we'll go to the elliptical curve, because nowadays, along with the RSA, people are using elliptical curve because I think key size is less. Okay. Now, for elliptical curve, the package is ECDSA. So, Python package which you have to install, again, same command, pip3 install ECDSA. Now, from ECDSA, you have to import two keys. One is the signing key. So, basically, it's the private key. And another one is the verifying key, which is the public key. So, two things you have to import. And again, since signing will be involved, so I will use hashlib for the hash function, SHA 256 or 384. So, we will start with the first part, where we have to generate the key pair. Because hashing is again same thing, hashlib you can use, and simply hashlib.hash256 you can use. So for private key, I am using signing key dot generate, and I'm passing it the parameter. So if you are using ECC, there are many curves. So I'm specifying which curve to use. So here I'm using P384 by NIST. So NIST 384 I'm using. You can use others also. You just have to remove it, and if I simply type NIST, you can see there are these curves. So there are other curves also. In the suggestion you can check, and whatever is as per your policy you can select that. And again, this time there is a simple command to PEM, which will convert it to a PEM file. And similarly, get verifying key is basically the verification key. And that also I'm converting to PEM. And finally, I'm opening one private ECDSA.PEM and one public ECDSA PEM to write the public key and private key. So this will basically create a private key file, and the other one will create a public key file. So only one command to generate, and you have to pass the which curve do you want to use for ECDSA, and simply to PEM is to converting it to PEM, and finally open the open a file for storing and save it. So one for private key and one for public key. So we'll see the generation part first. So EC key pair generation successful, and then we will see here in the side that there is one private ECDSA. So you can see here begin EC private key, and then there is a public ECDSA, which is simply begin public key. So key is generated. Now next part is the signing part. Now signing is a bit easy here. Many things it takes by default. So for signing, I am opening the private key file. So I'm reading it. And then there is a sign function in which I am passing only two things, message and the hash function. I can, if I do not write anything, by default it will take SHA 256. So you can remove it, it will still work. You just, but only thing is it will hash using 256 by default. And after hashing, basically I am saving the signature in a file dot signature. And finally, I'm printing the signature using signature.hex. Okay, so in between, whatever is going on, this all will be recorded, and this is already being recorded, and it will be uploaded on our channel. We have our website pkindia.in, and we have our channel youtube.com/pkindia. So where we upload all kind of tutorial. In fact, in the morning session you saw that also, learn.pkindia.in. That is also for learning purpose only. So all the material, there are quizzes, there are papers, there are PPTs, all the material is available online.
Today morning, your presentation will be also given answers. It will be there.
Yeah. We'll say, we'll put everything. So just one function. So first I am opening the file, and finally I am signing. And after signing, I am simply printing the signature. So I will just comment the generate part and run it again. And it will create one file, signature file. Oh, sorry. I should have uncommented the signature. So this is the digital signature. It's not as big as RSA because it is using ECDSA with only 256 size key. Sorry, 384. 384. And it also saves, but you cannot make sense of this.
The morning session, when in the Miswak sir session, we came to know that whenever before we are doing, we will be doing the CRL also. Whether validity of certificate is there, then only we do the signing. I was looking for you in this particular code. I didn't find that CRL verification before you do the signing operation.
So, so it's a simple demo, okay. And I have not included even the CRL URL. Okay. Because I don't have a CRL URL. Okay. So that's why I only included in the certificate things which can be shown for a demo.
Okay. Then second question is there any demo which you will be showing along with PKCS 11 library also?
Dr. Balaji.
Achha.
Okay. Yes, sir.
You have calculated both public and private key. You have created in both ECDSA and RSA, private and public keys, but only you have used the function like library. From one library, by invoking private key, you are getting private key. And in the same manner, you are getting public key. How public and private keys are reciprocate to each other? Because we know once private key is made, based on that only public key will be created. Here, like suppose if you are knowing the private key, so by using this library, we can again reveal the public key, or by knowing public key, we can reveal the private key only through this library. So it means in RSA, every certificate is there, public key is there. By using this library, we can recreate the private key. I'm totally confused that.
No. I think so here, whenever I'm generating the key, so I'm generating the private key, and the public key is being derived from that private key. It's single 5 like P12 wala.
So string is common, entire string, some portion.
From there the public key component, yes.
Some portion is the private, then it's okay.
So another function is a dot public key which will extract the public key portion.
From entire string, both private and public are created
simultaneously.
Out of which few strings are private key, and few strings are
public key.
Then you are
and I am encoding it using a passphrase.
No, like that. One is not If
not
you are
padding.
applying one function,
No, it's not padding. To be frank. So the public key, the private key, what is the public key? What is doing it? He is going to extract the private key by using the. That's why he showed the SHA-2 physics. So there is a concept of hashing also here. So where the message is getting hashed, again it's repeated back. It's like an implication of transmitting the public key towards the extracting the private key. It is not padding concept here.
the hashing comes later on.
No,
There
sir.
No hashing, only my key pair generation where hashing comes. Hashing comes
Hashing comes
after.
to the message.
No, hashing comes after once you are signing the message, then message digest and hashing comes, then after you applying the private key to make a digital signature. But here clear things are how public-private keys are being created. So I was thinking that just some one function firing the public key function, public key generated, private key function, private keys are generated. So how both are reciprocate to each other, because once
single
you
entity from single
then
entity
it
generate.
cleared, single entity in one shot, entire string was created, out of which some are.
Private key with the public key, it's not encrypted. That's what I'm trying to convey you. It is a thing, it is
No, I am
extracted.
not talking about the encryption, where
Extracted.
only extraction part is there.
Okay. And finally, the last part was the verifying the ECDSA. So here for verification, I will open the signature. So I had saved it into a SIG file. Of course, you can also put it in some variable, but practically you should save it in a file because that content has to be appended to the original message. So that's why this time I saved it into a file. So I'm reading that file, and this is my message. And finally, I am reading the public because I have to verify. So for verification, I need the public ECDSA. So corresponding whatever private ECDSA was there, corresponding public ECDSA I'm opening. So I'm reading from the file. And finally, I'm calling the verify function. So verify function, I'm passing three things: signature, message, and the hash function that I use for signing. So if it is successful, it will print digital signature is valid. Otherwise, I have put a try catch block, which will throw the exception. So I will uncomment it, run it. So currently it says that digital signature is valid. So I can simply make a change. For example, I can put a space and run it again. And it will say that digital signature the signature verification failed. Okay, so that's all. So I have only considered the soft part, means I am generating the public key, private key both, and storing it in some file with encoding, and then demonstrated the signature process, verification process. Again, I will repeat, only thing is there are various libraries. You have to consider which is the secure one. In the disclaimer, many bloggers which have written the code, they will tell that this is not the secure part. So you take the decision on your own and don't put it in production. But this code is good. Thank you.
Is this code is on any open source software?
This is the Python package.
No. Means the code you are shown, is it available on any open source?
Yeah, their documentation is available. Na? The whatever package are there, cryptographic package, na? So there is a thorough documentation available.
Like if I wanted this code.py file, how can I get this?
Which file?
Yeah.
He is asking about your code.
Acha,
This code.
I can put it on website, my website, but anyway, I also have taken these fragments from and customized as per my demonstration. So you can also take it from the documentation which is available online, and that you can search for Python cryptographic package documentation. So current version is 42.0.3 something. 42 is the latest one. Okay.
Now Python library can be embedded in Java or any applications.
Python can be integrated. Web application you can integrate with.
Python,
Framework is there.
PHP or something else.
Django framework is there. Otherwise, you can also put it as a web service. So Python will run as a web service and you call it as API.